How power plants work. Power plants are some of the largest machines humans regularly build. Entire facilities exist for one main purpose: turning one form of energy into electricity continuously. Coal, natural gas, nuclear fuel, flowing water, wind, sunlight. Almost every modern civilization depends on massive systems quietly generating electricity every second of every day. And most people only think about them when the lights suddenly stop working. So today we are going to walk through how power plants actually work and how large-scale electricity generation powers modern society. Power plants generate electricity by converting energy into rotational motion. That rotational motion drives electrical generators. Different power plants use different energy sources, but most follow surprisingly similar principles internally. The basic goal remains the same: spin a generator continuously. Many traditional power plants rely on steam. Water gets heated until it becomes high-pressure steam. The steam then flows through large turbines. As the turbine spins, it rotates a generator connected to it. Inside the generator, magnets move around coils of wire. This movement creates electrical current through electromagnetic induction, which is basically physics quietly doing most of the work while engineers build very expensive spinning systems around it. Coal power plants burn coal to heat water. Natural gas plants burn gas instead. Nuclear plants use controlled nuclear reactions to generate heat. Hydroelectric dams use flowing water directly to spin turbines. Wind farms use moving air. Solar farms use photovoltaic panels that generate electricity differently without spinning turbines at all. But most large power plants still rely heavily on rotating machinery. Steam turbines inside large power plants are enormous. Some are several stories tall. They spin at extremely high speeds continuously for years. Precision engineering becomes critically important. Power plants also require cooling systems. Steam must eventually condense back into water. Cooling towers and nearby rivers often help remove excess heat. Those giant cooling towers people associate with power plants are usually not releasing smoke. Most of the visible white cloud is water vapor, which is slightly less dramatic than movies often suggest. Modern power plants carefully control voltage and frequency. Electrical grids require stable electricity continuously. Generators must remain synchronized across huge regional networks. Even small imbalances can create large grid problems. Transformers increase voltage before electricity enters transmission lines. Higher voltage reduces energy losses during long-distance transmission. Power plants also contain massive monitoring and safety systems. Sensors continuously track temperatures, pressures, vibration, electrical output, and equipment condition. Operators monitor systems around the clock. Automation handles much of the routine control. Fuel supply systems vary depending on the plant type. Coal plants require enormous fuel transportation logistics. Gas plants connect directly to pipelines. Nuclear plants carefully manage reactor fuel and containment systems. Hydroelectric plants depend on water flow conditions. Renewable power plants depend heavily on environmental conditions like sunlight or wind speed. Power demand constantly changes throughout the day. Electric grids must balance supply and demand continuously. Power plants adjust output levels to match electricity consumption patterns. Some plants respond quickly. Others require much longer adjustment times. Backup power generation also remains important. Electrical grids require reserve capacity in case equipment fails unexpectedly. Reliability matters enormously because modern society depends heavily on uninterrupted electricity. Power plants also face environmental challenges. Different energy sources create different impacts. Air pollution, carbon emissions, thermal pollution, waste management, land usage. Modern energy systems involve large engineering and environmental trade-offs simultaneously. Renewable energy continues expanding rapidly. Wind, solar, battery storage, and modern grid systems are changing how electricity generation works globally. But regardless of the fuel source, the core goal remains the same. Generate electricity reliably and continuously at massive scale. Power plants became one of the foundational systems supporting modern civilization. Factories, hospitals, data centers, transportation systems, homes, communication networks. Nearly all modern infrastructure depends on large-scale electricity generation operating quietly in the background every second of every day. To wrap up, power plants work by converting energy sources like fuel, steam, flowing water, sunlight, or wind into electricity using generators, turbines, transformers, and electrical grid infrastructure. Most traditional plants generate electricity by spinning turbines connected to large electrical generators through electromagnetic induction. Cooling systems, fuel supply networks, monitoring systems, and grid synchronization help maintain stable electricity production continuously. Modern power plants became one of the most important infrastructure systems supporting modern civilization and global energy networks. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.